Hello everyone, my name is Priyanka and I welcome you all to my session. So let's study a question which says that calculate the potential difference and the energy stored in the capacitor C2 in the circuit shown. Given the potential at A, which is 90 volts, C1 20 microfarad, C2 as 30 microfarad and C3 is 15 microfarad. So for solving it, let's just first write down all the values. So C1 is given to us as 20 microfarad. C2 is given to us as 30 microfarad, and then C3 is given to us as 15 microfarad. Also the potential is given to us as 90 volts. So we have to find out the potential difference across C2 and also the energy stored in this capacitor. Alright, to finding it, first we have to find out the equivalent capacitance of the circuit. Because the capacitors are connected in series, therefore the formula is 1 by C is equal to 1 upon C1 plus 1 upon C2 plus 1 upon C3. So I'll just put in the values 1 by 20. Just remember that all these capacitance are in microfarad. So our answer, that is the final answer, should be in microfarad as well. So here, instead of taking LCMs, what I do is I just multiply all the denominators together so that I don't make any mistake in finding out the LCM. So it is 30 into 15 plus 20 into 15 is 20 into 30. So 1 by C comes out to be 450 plus 300 plus 600 upon 9000. So reversing the values, C is going to be 9000 upon 1350. So we can just cancel it further. So it is going to be 300 upon 45. That's just the simple mathematics that we do. Dividing it by 3, 15 here, and then by 5. So it's going to be 20 and 3. So our answer for equivalent capacitance comes out to be 20 by 3 microfarad. Now let's talk about the charges. Now we know that when the capacitors are connected in series, the total charge remains the same. Therefore, what we can do is that we can find out the charge across the capacitor C2, and then which can help us to solve further about the potential difference. So we are knowing that Q is equal to CV, which implies that we have to just find Q. So we have found out the equivalent capacitance, which was 20 by 3, because it was microfarad, therefore minus 6, and the potential is given to us as 90. So cancelling it, our answer is going to be 600 into 10 to the power minus 6. So our answer is going to be equal to 6 into 10 to the power minus 4 coulomb. Okay, now the potential across the capacitance C2, we can write it as Q is equal to C2 into V2 that we have to find out. So the charge we have already calculated as minus 4, 6 into 10 to the power minus 4. C2 we are knowing it is equal to 30 into 10 to the power of minus 6, and V2 we have to find out. So V2 is equal to 6 into 10 to the power of minus 4 upon 30 into 10 to the power of minus 6. So you can calculate further and your answer is going to be equal to 20 volts. Now the energy, we are knowing the formula of energy, which is equal to half CV square. So it is half into the capacitance, that is C2, and this is V2. So C2 was 30 into 10 to the power of minus 6, and V2, the value of V2 we have just calculated, that is 20 into 20. So it is going to be 10. So calculating it further, we are going to get our answer as 6 into 10 to the power of minus 3 joules. So this is how we are supposed to do such kind of questions. The important thing that we have noted down and used as well is that the charge in the series connection is always going to remain same, and that's the concept we have used. Always remember this thing, that when the circuit is connected in parallel, the potential is the same, and when it is in series, the current or the charge is going to remain the same. So pay attention to small details of the question and you can easily be able to do it. So thank you so much for your time. Have a really great day. Bye bye.